Welcome. In this video, we'll be discussing again how to find the greatest common factor of two monomials. So if you haven't watched the video that I did previously on finding the greatest common factor, watch that one before you watch this one. So just as a review, the greatest common factor is the largest term that both originals can be divided by with no remainder. So what I mean by that is, let's take a look at an example. So let's suppose that we're trying to find the greatest common factor of 6x to the third and 9x to the fifth. Well, really, I break that down into two pieces. The first piece is if we just look at the coefficients, the 6 and the 9, what's the largest number that goes both into 6 and 9 with no remainder? Well, that number is going to be 3. So part of our GCF is going to be 3. The second part of it is looking at the variable pieces. So looking at this guy, since it's x to the third, that means we've got 3 factors of x. X to the fifth is 5 factors of x. So if I look at the number of x's that both terms have in common, well, I see that we've got an x here and an x here. That's one x in common. I see we've got another x here and another x here. That's 2 x's in common. And I see another x here and another x here. So we have 3 factors of x in common. Okay, so since we've used all these x's up, basically we're done with the x's. So, and since there's really nothing left, our final answer is just going to be the 3, the largest number that went evenly into 6 and 9, times the x's they had in common, which was 3 factors of x. So our final answer, the GCF, is 3x to the third. Okay, let's take a look and see how we might do number 1 on this sheet. So number 1 was find the greatest common factor of 15u to the 6th, x to the 8th, z to the 6th, and 10x squared, z to the 6th. So the first step in the process is just finding the greatest common factor of 15 and 10. So that's the largest number that goes evenly into 15 and 10. Well, that number is going to be 5. So the first part of the process is complete. The second step then is we're going to look at the variable pieces. So the variable piece for the first term is u to the 6th, x to the 8th, and z to the 6th. And the variable piece for the second term is x to the 2nd and z to the 6th. Let's see if we can find a shortcut in our example so we don't have to write everything out. Well, notice that each of these original terms had x's in them, had factors of x. This one had 3 and this one had 5. Which one ended up appearing in our greatest common factor? Well, it turns out the smaller of the two did. So the reason why is once we've used up those x's with the x's in the second term, then there are no other x's for this first term to share with these 2 extra x's in the second term. So when I'm finding the greatest common factor, what I'm going to do is look at each variable, but I'm only going to take the one with the lesser power. So let's start over here with the u's. So this first term had u to the 6th. The second term doesn't have any u's. Well, what that means is in my greatest common factor, I can't include any factors of u because this guy doesn't have any. The second part is to look at the x's. So this first guy had x to the 8th. The second guy had x to the 2nd. So again, I take the lowest power, and that's x to the 2nd. So my greatest common factor for the variables is going to start with x to the 2nd. And now if I look at the z's, this guy has 6 factors of z. This one has 6 factors of z. Well, that means my greatest common factor is also going to have 6 factors of z. And so the final step in the process is just multiplying step 1 and step 2 together. So we've got overall our GCF is going to be 5 times x squared z to the 6th. Okay, let's try one more. Let's try number 2 and see if we can come up with an answer. So number 2, the first thing we look at is just the numbers in front, the 16 and the 30. And what we're trying to figure out is the largest number that goes evenly into both 16 and 30. So that number is going to be 2. And now I look at the variable pieces. So I'm going to start with the t's. So this first term has t to the 4th. The second term doesn't have any t's. That means my greatest common factor can't have any t's either. Now if I look at the x's, the first term is x to the 7th, the second term is x to the 8th, so I take the smaller of the two, which is x to the 7th. And then if I look at the z's, the first guy has z to the 3rd, the second has z to the 1st, so I take the smaller of the two, which is z to the 1st. And that's my answer. If I were writing this on Alex, the way I would write it is I wouldn't put the 1 power on z, I would just leave it as z. Okay, I want you to try numbers 3 and 4, pause the video, and then restart after you've given them a try. So for number 3, the greatest common factor, well, first of all, if I look at the two numbers, the largest number that goes both into 7 and 14 is 7. Then if I look at the t's, this one has t to the 3rd, this one has t to the 6th, so I take the smaller of the two, which is t to the 3rd. If I look at the w's, we've got w to the 2nd and w to the 3rd. I take the smaller of the two, which is w to the 2nd. And then z's, this guy has z to the 4th, this one doesn't have any z's, so that means I can't include any z's in my answer. And then for number 4, well, if we go through the same reasoning, first step is to look at the coefficients. The largest number that goes evenly into both 10 and 5 is 5. And then if I look at the x's, we've got x to the 8th and x to the 9th. That means I take the smaller one, which is x to the 8th. If I look at the z's, we've got z to the 6th and z to the 1st. So again, I take the smaller, which is z to the 1st. And then this guy has w's, but this one doesn't. That means I can't include w's in my answer. And again, if I were writing this on Alex, I wouldn't include the first power here. I could just write that as 5x to the 8th z.